Hi, this is Benny Low again. This video is a follow-up to my previous video on solving linear equations. In this video, I'm doing some more interesting or more challenging examples on solving linear equations. So for example, in example 1 here, solve for t. The variables here is t for time. I have 1/2 t minus 3 equal to 4t. The first step I recommend is to clear the fraction. You have 1/2 here, so how do I get rid of the 1/2? I would multiply both sides by 2. So you will multiply both sides by 2. You have 2 here, 1/2 t minus 3. On the right hand side, multiply 4t by 2, so 2 times 4t. So 2 and 1/2 cancel out, so you have t minus 3 times 2 is minus 6 equal to 2 times 4 is 8t. Now the next step is to combine like variables. You have t here, you have 8t. As a reminder, when I was in junior high, I was taught by my teacher under the British system that you may move a variable from one side to the other, and you simply change the sign. So I keep 8t on the right, the t on the left, bring it over to the right hand side. There's a positive t on the left. When I move it to the right hand side, it becomes minus t. Keep the minus 6 on the left. Then you have 8t minus t is 7t, and then you have minus 6. One more step. How do you get rid of the 7? You may divide both sides by 7. So you divide both sides by 7. 7 over 7 cancel out, so you have 1t, and the answer here is minus 6 over 7. This is a proper fraction, so usually I would just report the answer as t equal to minus 6 over 7. So just to summarize, whenever you attack a problem like this, when you have fractional coefficient, you first clear the fractions. In this case, just 1/2. So you multiply both sides by 2. Then you have 2 on the left, 2 on the right, and then clear the fraction. Make sure you multiply the whole quantity by 2. Don't just multiply 2 by 1/2, right? That's a common mistake. And then when you get to this step, you simply divide both sides by 7. 7 over 7 becomes 1. So you have t equal to minus 6 over 7. It's customary to write t, the variable, the unknown, on the left hand side. So that's the first example. So next, let's do a second example here. In my second example, I solve for x. Sometimes the variable may be in x, t, or y, or whatever. In this case, x. It's very common in most textbooks is x. So 1/3 x minus 5 equal to 1/2. So you keep the variable on the left, 1/3 x. The minus 5 here, you may bring over to the other side. So you have 1/2 plus 5. There's a negative on the left hand side. When you move it over, you change the sign from negative to positive. You have 1/3 and 1/2. So how do I clear the fraction? What's the common denominator between 3 and 2? 2 times 3 is 6, right? So you multiply both sides by 6. So just write down 6 times 1/3 x. By the way, the dot means multiply. You have x here, so you don't want to put another clause here. It'll be too confusing. So I use a dot. So I have 1/2 plus 5, the whole thing, put parentheses. You multiply both sides by 6, right? So balance it out. I'm multiplying both sides by the same thing, 6. Why 6 again? Because 2 times 3 is 6. That's a common denominator. So 6 over 3 is 2x equal to 6 times 1/2 is 3 plus 5 times 6 is what? 30. Then you have 3 plus 30 is 33, and then you have 2x. One more step. You have a 2 here, and you're trying to solve for x. How do you get rid of the 2? You divide both sides by 2. So you have 2 over 2 is 1. 33 over 2. You can figure it out. So 1x equal to 33 over 2. This is an improper fraction. What do I mean by improper? 33, the numerator is bigger than the denominator. So you may report the answer like this, or you may report the answer as a mixed number. So what is it? So you sum 33 divided by 2, you have 1 here, carry 1, you're 6, you have 1 over 2. Well, let's double check. 16 times 2 is 32, 32 plus 1 is 33. So this is a mixed number, 16 and a half, or as an improper fraction, 33 over 2. As a check, you can plug in 33 over 2 into your original equation to see what you check out, right? Let's double check. So 33 over 2, you plug it in, you have 1/3 times 33 over 2, right? So as a check, let's verify it. So check. I have 1/3, plug in 33 over 2, minus 5 equal to, is it 1/2? 33 over 2 times 1/3, 33 and divided by 3 give you what? 11 over 2 minus 5. Is that equal to 1/2? So on the left hand side, you have 11 over 2. 2 times 5 is what? 2 times 5 is 10. You have 11. 11 minus 10 is indeed 1. 1 over 2. So check out. So that's the way to check. We just verify that indeed the answer is 33 over 2 or 16 and 1/2. Okay, as a last example, I want to show you a third example, solve for y. The given equation minus 2y minus 5 equal to 1/3 y. So before I show you the complete solution, I'd like to ask my viewers or my audience to pause a video, because you must be on YouTube. Pause a video. Let's try to solve this simple equation on your own. Remember, I'll give you a hint. You have to clear the fraction, right? That's 1/3 here. So you have to multiply both sides by some number. So figure out what number you want to multiply both sides by, and then spend about 5 to 10 minutes to try to figure out. If you cannot figure out in about 5 to 10 minutes, come back to the video to see the solution. So pause the video now, please. Alright, I'm back now. So did you figure it out? So first, you have to multiply both sides by 3, right? Why 3? Because you have 1/3. So let's try it. Multiply both sides by 3. So 3 here. And minus 2y minus 5 equal to 3 times 1/3 y. 3 times minus 2 will give you minus 6y. 5 times 3 is minus 15. Be careful, this is a minus. Keep the minus sign. It's another common mistake. Students sometimes forget to put a plus, right, instead of minus. And 3 and 1/3 give you 1y. So now you have minus 6y, y. I like to bring the minus 6y to the right hand side, so y plus 6y. Remember the rule is negative on one side. When you bring it to the other side, it becomes positive. So keep the minus 15 here. So you have 6y plus 1y is 7y and minus 15. One last step. You divide both sides by 7. 7 over 7 is 1y minus 15 over 7. So you customary to write your variable or the unknown on the left. So minus 15 over 7. Is this a proper or improper fraction? The way to tell is, in this case, the numerator bigger than the denominator, 15, right? So this is an improper fraction. So you may report the answer as a mixed number. So how do you do that? 15 divided by 2 give you what? 2, right? 2 times 4 is 14. So keep the minus, the 2, and then you have 7 here on the bottom. This is 7 at the bottom. And what do you have left? So 1. Let's double check. 7 times 2 is 14. 14 plus 1 is 15 indeed, right? So how do you check whether your answer is correct? You may plug in minus 15 over 7 into the given equation, like into this y here and into this y here, and check on both sides. So I leave it as an exercise for you to check, right? It should be correct. Alright, so I hope these 3 examples help you out. Remember to clear the fraction. So these are more complicated examples than before. If you need more simple examples, go to my previous video. under my channel, Benny Loves Math. So I hope this video helped you out. So feel free to give me some feedback. If you have any more questions or you would want to request some more videos, let me know. Alright? Have a great day.